Okay, this is P6.6, the Drunkard's Walk. I'm going to make a new project. Java application. Called the Drunk Walk. Put it in my location where I can find it. Finish. So I have my basic application. Okay, so I'm going to have two classes in this, in addition to my main, just to extend it a little bit. So I'm going to do a new Java class. I'm going to have the drunk, and I'm going to have a new Java class called position. My position it's going to have my X and Y location, and then the position will be able to return the X and Y location. Okay, I can set the X value. I have int X here is a local variable to this method. The X up here is an instance variable. So this variable hides this variable. So if we want to refer to the one that's part of the object, you have the this keyword. This.x refers to that X. It's easier. If you just use different names. Okay. Now our position can also do four things. It can move in a particular direction. So the different directions that we can move are north, south, east, and west. It doesn't really matter what these numbers are, as long as they're different. So these are constants that are declared, and they're public, so we can actually get to them from outside of this class. Static means that they are a class level variable. Final means they can never be changed. Int is its type, and these are capitalized by convention. And again, we just need to have these separate. So another thing that a position can do is move in a direction. Okay, so I can do a switch statement or an if statement. So if north is my direction, that means my y value goes up. If south is my direction, my y value goes down. So we're going up and going down. Okay. Else if east is the direction, it means we're going right on in app or right on the screen. So that means X is going up. And I'm not going to put an if on here. We're just going to assume anything else is going west, which means going that way. So even if I give it a direction of 25, which doesn't match one of these, that will be west. Okay, so this will take care of our current position. We can initialize this. Initializing X and Y to our default position of 0, 0. So now I have a little class that can keep track of my position for me. So now the drunk over here has a current position. Okay, so when I create a drunk, I create a position. This makes it currently at 0, 0. Okay. Now, the drunk can randomly walk in one of 4 directions, so we need a random number generator. So it sets up a random number generator. This is saying that these can both be final because the actual object isn't going to change the pointer, even though the value might change inside of the object. So we can make them final. All right. So we need to tell the drunk to be able to walk. So we need a random number. The next int between 1 and 4. Actually, this makes it 0 and 3. So if we go back up here, we've got 0, 1, 2, and 3. So this will be the position that we get. And we just tell the direction to move in that direction. Okay, so every time we tell the drunk to walk, it's going to randomly pick a north, south, east, or west and move in that direction. Okay, so we need to be able to ask the drunk where he currently is. And I think that's about everything we need in that one. So now in our drunk walk, here we just create a drunk person. And we make them walk 100 times. So since we have a known amount, we can use a for loop. So this will run exactly 100 times. Tell the person to walk. And when we're done, we need to know where the person was. this is a printf instead. Okay, present D's for decimals. So we get the person to give us their current position. From the position, we get the current X. Now we get the current Y, and that would be our ending position. So now we can run it and test it. Here our ending position is -5, 15. Notice we don't have the space in there. So we can go back and put a \n to get our new line. Put a couple in there. And put one at the beginning. Rerun this. So it gives me a little bit of space there. So our ending position, -3, -5. We run it again, 14, -4, -4, 2, 11, 5, 3, 3. And that would be the end of this particular program. Now as an extension, instead of going 100 times, I'm going to wait and see how many times it takes for the drunk to get out of the grid itself. Our grid is 100 by 100, which means they go -50 to +50 in the X and Y directions. Okay, so instead of this, I'm going to keep going forever and count how many times it takes. Okay, so instead of a for, I'm going to do a while loop. And I want to go while the person's X value is greater than or equal to -50 and the X position is less than or equal to 50. It means they're in our grid somewhere still. And just like that. And I want the same thing for the Y locations. I'm just going to copy that, put it there, and change these to Y's. Okay, so as long as that is true, we tell the person to walk and increment our count. So count plus plus or plus plus count is the same thing as count equals count plus 1. So while the person is still in the city, we add 1 to the count. Eventually they get out, an ending position, and the number of steps that they took to get out of the city is whatever my count is. So if I run this, it's kind of like the same thing as before, except this time it ran 3,115 times until the person finally got out of the city, and this is a -51, which means they went south, out. Here's a -51 on the X, which means they went to the left, which is to the west, and they left, and it took them 9,202 times to get that one. Here's 948, 900, 2,000, 2,000, almost 4,000, 5,000. Okay. So the drunk randomly walks around, but eventually exits the city.